Okay, students, we're going to talk about graphing inequalities. We'll first do them linear, and then we'll do them with systems of linear. Okay, so this is pre-algebra and algebra 1. So first off, you have to recall your inequality symbols. 5y is greater than, so you got to know that's greater than. And it has nothing to do with if it's always pointing to the right, that means greater than. No, it depends where the variable is, the y that you've solved for. Okay, you read it from the y. So, for example, that is also greater than, because y is greater than. It always points, if you want to think of pointing, it points to the smaller. So it's pointing, there's the pointing, it's pointing to the smaller number. So the one on the other side is the greater. Okay, and that would be dashed and shaded above. Okay, greater than. If I add in greater than or equal to, okay, then it's solid. And I'm just going to say above. I'm not going to keep writing dashed again. Okay. So, example, and of course, that could be read as y is greater than, if it's the y is on the right side. That's y is greater than or equal to. Okay. All right. So, example, and we're talking like if it's in slope-intercept form. Y is greater than 2x minus 3. You should know my slope is 2 over 1, and you always write it as a fraction. Arrows on it, up to right 1. Y-intercept is 0, negative 3. And which one of those is a point? Only the y-intercept. The slope gives directions. Okay, it's not a point, so you can't plot the slope. That's common error pre-algebra and algebra 1 students who are weak. Okay, so I start at 0, negative 3, and I go up to right 1, up to right 1. And since I look at my inequality symbol, this is one thing I would suggest you do. I don't have room to write above. I usually write above it, but I'd say dashed and above. Okay, that symbol, so that means I dash the line and I shade above. Now, how do you know which one is above? When I say above or greater than, that means in relation to the y coordinates. So if I draw any vertical line right here, I'm comparing those y coordinates with these y coordinates. Which y coordinates are greater, the purple or the black? Obviously the purple is greater. So this is the greater than side, above right there. Okay. And if you need to, you can plug in a point to check. The easiest point to plug in is 0, 0. You can do that every time unless 0, 0 is on the line. Then obviously that doesn't do any good. You got to be on one side of the line or the other. So 0, 0 would work. I plug it in. I get 0 is greater than negative 3. Is that true? Yes, it is. So 0, 0 is on the side that should be shaded. This is true. If that came out to be false, then I would notice shade on the other side. Okay. So we have that. Go ahead and pause the video, write it down if you haven't written it all down yet, and I'm going to erase and go on. Okay, so now we have less than. Y is less than, or y is less than or equal to. Okay, and of course, if I put y on the other side, there's y is less than, or y is less than or equal to. Okay, and we always read it from the variable y, and it points to the smaller one. So it's pointing to y. So that means y is less than or equal to. Okay. So for that, again, you'd have either dashed and below or solid and below. Okay. So let's say I have y is less than negative 2x plus 1. So my slope is negative 2 over 1, arrows down and to the right. Y-intercept is 0, comma 1. Which one's a point? Only the y-intercept. The slope only gives me directions. So now I follow my directions. It says go down 2, right 1. Now it says go down 2, right 1. Here's another common error that weaker students make, is they think they can start at the origin and go down 2, right 1. No, these directions are only from another point that's already on the line. So the only point that I've graphed on the line so far is 0, 1. So I have to go from there down 2, right 1. Down 2, right 1. Now, the other thing you have to know to do is, or be able to do, is I could put that negative in the denominator. 2 divided by negative 1 is still negative 2, just like negative 2 divided by positive 1 is negative 2. So that would tell me to go up 2 and left 1. So I can go up 2 and left 1. And you see that's still on the line. Up 2, left 1, that's still on the line. Since this does not have an equal sign, it's dashed. Okay, and I would have written dashed below. Okay, for less than. So again, if you're not sure which is less than, draw a vertical line and compare those y coordinates. Which y coordinates are less, the purple y coordinates or the red y coordinates? The purple y coordinates are less than. So I'm going to be shading on the bottom side here. Okay, it's that simple. You'll be doing this in 7th or 8th grade. Okay, so this is all review. You need to be able to do both sides, whether y is on the right side or y is on the left side. You have to be able to understand and read it correctly from both sides. You also have to be able to know that I can switch the negative sign from the numerator to the denominator and still get points on the line using those directions. Okay, from a point already on the line, such as the y-intercept. Okay. All right. Now, why do you need to be able to switch like I did in this last piece right here? Why is that necessary? Well, what happens if I have this equation? If I have y is greater than or equal to negative x plus 5. No, positive x plus 5. We'll go. Well, I'm now starting at the very top of my graph right here. And a positive will be up 1 and right 1. I can't just plot that and guesstimate that. But what I can do, so that slope is 1, which would be up 1, right 1. But what I can rewrite that as negative 1 over negative 1. That also is positive 1. So now it says I can go down 1, left 1, down 1, left 1. That now allows me to get an accurate graph, okay, with points in the coordinate plane that I can graph. That's why you need to be able to know to switch the signs, or sign if it was only a negative. If it's positive, both signs have to get switched like this. And then it says greater than, so of course that means above. I would shade above. Okay, so if you have to pause the video to write any of that down, write it down because I'm going to erase now. All right, so now we have horizontal and vertical lines. Those are oblique lines, right? When I have it in slope intercept form, that's oblique. There are 3 types of lines: horizontal, vertical, and oblique. So now I could have y is greater than or equal to some number. That is a horizontal line. Okay, and of course that'd be solid because I got the equal sign, greater than, maybe shade above. Or I would have x is some inequality sign equaling to a number, and that's a vertical line. And of course, that does not have an equal sign, so it's going to be dotted or dashed, and it's going to be shaded to the left. Okay, so we'll look at some examples and why you know it's horizontal or vertical. It should not be difficult to understand this, so if you have difficulty memorizing which one's horizontal and vertical, you just pay attention right here. So let's say I have x is greater than -2. If I make an XY t-chart, does it say anything about the y values in that inequality? No. So y values can be anything, but x has to be -2. Y can be anything. Try to take x -2, 2 or 3 of them, because you need 2 points to make a line. And y, is pick 2 different points. So -2, 0, -2, 1, and -2, 2. I know it's dashed because there's no equal sign. Okay, so now I already know it's a vertical line right there. So I don't have to memorize that. I can just plot that down just like that if I needed to. So I have it memorized. Okay. Now it says x is greater than -2. So we're comparing all the x values. Again, we only have x here, so comparing the x values. Where are the x values greater than -2? The x-axis is right here. So the x values along the x-axis. All of these values to the right are always greater than anything to the left. So this is the greater than side. -1, 0, 1, 2 is all greater than -2. Okay. Versus if it said less than, then I would shade to the left. Okay, now let's say I have y is greater than or equal to -4. I know it's going to be solid and above is greater than. Okay, so I look to write that so I don't forget. I'm using that as a reminder when I'm done. Did I make it solid and did I shade above? Again, XY t-chart. It doesn't say anything about x's. I can't plug any x's in, so I can plug anything I want for that. Y has to be -4. X can be anything. Okay, so 0, -4. 1, -4. 2, -4. So I can see I have a horizontal line. It's going to be solid and shaded above. Now when I say above, all these y values are greater, -3, -2, -1, 0 going up like this, are greater than -4. Because I'm just comparing the y values, because it's y equals, okay? So over here, when it's x equals, I'm comparing the x values. When it's y equal, or with the inequality sign, I'm comparing the y values. Should be very easy to understand. Hopefully, you've already been taught this in middle school. Okay. All right. So now we've dealt with any possibility. No, we got one more for positive. You need to write any of this down. I'm erasing. Okay. So we have it x equals, y equals. We did y equals mx plus b. Slope-intercept form. Now, if we give it in standard form, 2x minus 3y is less than 6. Okay, standard form. Ax plus by equals c. A, b, and c have to be integers, and a is positive. This is true standard form right here. Okay, should have learned standard form algebra 1 already. Okay, before getting to inequalities. All right, so the two easiest points to plot in the standard form are the x and y intersects. Okay, you should have that memorized. Well, if your Algebra 1 teacher has already taught you this, or if this is the first time you're in Algebra 1 right now watching this video, you now know it and you need to memorize this. X and y intercepts, what does that mean? It means we're across the x-axis and we're across the y-axis. So, x-intercept, what do you know is true about the x-intercept? Any point on the x-axis, any of these points, I'm just picking integer points. Obviously, it can be any point. What is in common with all those points? That means which coordinate is the same on every one of those points. You should know by now, the y coordinate is 0 on every one of those. The one that changes is the x coordinate. The y coordinate never changes. So what that means is I plug in 0 for y. So I plug in 0 right there for the y. Okay, and it wipes that out. Wipes that whole thing out right there. So I just get 2x equals 6. So x equals 3. So 3, 0 is the x-intercept. Now the y-intercept. Which coordinate is the same on every point on the y-axis? Again, I'm just picking integer points. Which point is the same? If I name all those points, which one doesn't change? 0 for the x coordinate every single time. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, etc. So this means I plug 0 in for the x coordinate in order to get the y-intercept. So now I have negative 3y equals 6, so y equals negative 2. So 0, negative 2 is the other point, the y-intercept. Remember, I only need 2 points to make a line. Now, I don't have an equal sign underneath that less than right there, so I go ahead and make it dashed and graph it. Now I got the line drawn. Now, here's the key you need to remember if you're now not going to solve for y and you want to just now know which one is shade. I look at the coefficient of the y only, negative 3. If it's negative, I must switch the inequality sign. So it means it's greater than. And so the greater than sign, remember comparing the y coordinates, the greater than sign is above, right there, and there's my answer. Now again, I've already told you how you can check if you wanted to anytime. The easiest point to check is 0, 0, and that's not on the line. So I plug in 0, 0, I get 0 minus 0 is 0 is 0 less than 6. Yes, it is. So 0, 0 is on the correct side of in the shaded region. Okay, so you can always pick 0, 0 unless 0, 0 is on the line itself. Easy to plug in and to check to see if it should be on the shaded side or not, if you need to do it that way. Okay, so that's one way to do it if it's in standard form. Okay, so now I'm going to do it 2 other ways. That's how I would teach to do it. Okay, and if you're not confident about the switching the signs, you can just immediately pick a point, any point you want, such as 0, 0, plug it in. If it comes out to be true, you notice shade on that side of the line. If it comes out to be false, you shade on the other side of the line. Very simple. Okay, you can do that at any time for any of these inequalities. Okay. All right, so now if I have 2x minus 3y less than 6, and I want to solve it for y and put it in slope-intercept form, because some of you like to graph from slope-intercept form much better or all the time. I don't recommend it. If it's in standard form, I use the x and y intercepts, but again, some teachers just continually teach you to do it one way, which would be solve for y. And so I'm going to show you my way of solving for y, what I believe is the smartest way by far, or the typical way a lot of teachers teach it. And I'll show you errors along the way that commonly come up. Okay, so Carlson way. You look at the y coefficient. What is the y coefficient here? Negative 3. If it's negative, you are moving that y term to the other side to make it positive every single time. This does not change if it's an equal sign or not. This is how I always teach it. Okay, so that's negative, so I'm going to add it across to move it over there to the positive side, which means I need to move the 6 across. So of course I'm trying to solve for y. So now I have 2x, move 6 across, becomes negative 6 less than 3y. Okay, and I have one last step to do. Divide each term by 3. Remember, a term is separated by plus or minus signs. So we have 3 terms here. And then simplify that. Y is greater than 2/3 x minus 2. Okay, there's my answer for my slope-intercept form. And then I go ahead and graph it. So start at -2 right there and go up 2, right 3, and it gives me that point right there. Okay, but notice I had to do that work to get those 2 points. It was real quick to plug in 0 for the x, solve for the y, plug in 0 for the y, solve for the x in standard form, and get those 2 points right away much quicker. But if you want to go ahead and solve for y, that's the smartest and best way to do it. Nothing complicated right there. Now, this one right here, this is a way that several teachers will teach it where they want to leave the y on the left side no matter what. Here's the problem with that. You have a lot more increase for errors in this particular situation. So if I'm going to solve for y here and leave y on the left side, that means I'm moving the x term across. So now I have negative 3y is less than negative 2x plus 6. So first off, one common error is students forget to bring down the negative 3. Okay, and that blows their answer. So next, I need to divide each term by negative 3. Okay, and students will often write this then. Okay, so here's another chance for error. Students forget this negative sign down in the denominator here, and they just write down negative 2/3 x. So not only do you remember that, but now I have changed the negative to a positive. Okay, notice I didn't have to do any of that over here on my way. Okay, so that's another common error that students make. Now the last common error that students make, which is the biggest one, because you have to remember all these little rules when you do it this way. You don't have to remember when you do it my way. When you do it this way, and this is what a lot of A students just did on the recent assignment, and B students, is when I divide by a negative or multiply by a negative in an inequality, I must switch the inequality sign, and they forget to do that. And so it makes them shade completely on the wrong side. Okay, so now you have to remember that rule as well. And now you see you get the same thing. Y is greater than 2/3 x minus 2, just like we have right over here. Okay, there's 3 chances right there. Forget to drop down the negative. Then if you remember to divide by negative, another common error, so they forget to divide by -3 and they just do the positive 3. That blows it. Then when you divide by the negative, you have to remember when you have a negative over a negative, you change that to a positive. And then lastly, you also have to remember to switch the inequality sign. Notice I didn't have to remember any of that stuff. I did it my way right here. Always make the y coefficient positive right away if you're going to solve for y. And that doesn't matter if it's an inequality or if it is a equation, just an equal sign. Same rule applies. Do it. First thing I'm looking for, if I'm solving for y, I'm looking at the coefficient of y, asking is it positive or negative. If it's positive, I'm keeping it on that side, move everything else to the other side. If it's negative, I'm immediately moving it over to the other side to make it positive, and then put everything else back to the other side. Okay, so those are things, 3 different ways: standard form, x and y intercepts, Carlson way, making the y coefficient positive right away, or the long and more complicated and much more chance for error, typical way that a lot of teachers will teach it over here in the last one. If you do all these steps correctly and don't forget any of them, you'll still get the right answer. Okay, but you have to remember all those. A lot more things to remember, therefore increased chance for error. So it's your choice now. All right, I'm going to stop there and then I'll do a new one with systems of equations.